This is what nitrile is. That's carbon with triple bond attached to nitrogen. So this functional group itself is called nitrile. So it's called nitrile. Are you getting it? So when you, for example, when it appears in a compound, for example, we can call it in. Look at, let's say, okay, let me just write C here. Okay. Here C, here 2, and then 2. Alright. So when if you want to name this compound now, you will name it 1, 2, 3, 4. That's butane nitrile. I get what I'm saying. You will still count the number of carbons. 1, 2, 3, 4. So that's how to name nitrile. That's butane nitrile. So in that box, they are trying to tell you that okay, when you want to name them, when they appear in functional groups, you give the name you give to them. Alright. So that's that. Okay, like I established earlier. Now the next box is talking of minor functional group. Minor functional group. Alright. So look at here now. In the minor functional group, they talk of chloride. I established to you earlier that when you see chloride in a compound, it is called chloro. Okay, let me write this down. That is butane nitrile for the reference point. That's butane nitrile. Alright. So I established something earlier that when you see chlorine in a compound, you call it chloro. When you see fluorine, that's chloro. So all those things like that. So when you see alcohol, that's hydroxy. So that's and I mentioned to you earlier. So we are talking of what I first discussed is the major functional group. Now we are talking of the minor functional groups now. Okay, so we are talking about the minor functional group now. We are talking about that's the functional group that appear as substituents. I told you earlier that when you see aldehyde and ketone together, so you give aldehyde priority and you will name ketone as a substituent. So now look at the box now. They said ketone is oxo. So that's when it appears as a minor functional group. At that point it will be called oxo. The same thing for aldehyde. When it appears as a minor functional group, it will be called formyl. So that is established in the box already. Alright, so let's get over that. Alright, so now let's move on. We are now on drawing organic structure. I've shown you some of this on how to draw organic structure. So we have the three major ways of drawing it here. We have the careful structure. So that's the basic one we have been doing since morning, the careful structure. Now this structure here, now this is the careful structure of drawing organic compounds. Can everyone see the board? Okay, I thought it would be blocked. Okay, so this is the chemical structure of organic compound. So now we have the condensed structure. So when you are talking of the condensed structure, you are talking of, let's say I want to write pentane now, and I'm now writing, okay, let's say I want to write pentane. So if I want to write that CH3, CH2, CH2, CH3, 1, 2, 3, 4. So this is the condensed structure. So this is the chemical structure, this is the condensed structure. So that's it. So now when you talk of the skeletal structure, that means you are talking of structure like this. Are you getting it? Similar to what I told you the other time. So where each edge represents a carbon. So this carbon, this carbon, this carbon, this carbon, this carbon, and this carbon. Alright. So that's that. Let's draw the structure of two. I want you to quickly do two things. Let's start with the structure of 2-pentyne. Have I really discussed? Okay, I've not done much on. Okay, let me do it. I've not done much on the alkynes. Okay. Hello. Please let's listen. Now this is the alkyne. Alkynes have the general formula CnH2n minus 2. Am I right?
Yes.
CnH2n minus 2. So we are on exercise 1 now. So that's D. This says that you should draw the structure of the careful structure and the skeletal structure of 2-pentyne. The careful and the skeletal structure of 2-pentyne. The careful condensed and skeletal structure of 2-pentyne. Okay, now listen. We want to draw for 2-pentyne. So that will be, we have our C as usual. So we have our C as usual. C will be what? 1, 2, 5. So we are drawing 2-pentyne. So that means the triple bond will be on the second carbon. Do you get that? So let's go. 1, 2. So our triple bond is here. Can you see? Yeah. So the same way. So 2-pentyne, we are drawing 2-pentyne. So we follow the same rule that carbon must be welded to just 4 atoms. So when you follow you discover that this one already has 1, 2, 3, 4. You discover that no hydrogen can be attached to this carbon here. And the same thing with this carbon, no hydrogen can be attached here. Are you getting it? So that's just the basic principle you follow. Okay. Now, if you now want to draw the structure of 2 pentyne, it will now simply be this: 1, 2, 3, 4, 5. Are you getting what I'm saying? Then you count 1, since there is a carbon here. Are you getting it? 2. Then you put it here. So that will be, you have your, that's your 2 pentyne. So the same way for 2 hexyne. Yes. 2 hexyne we just extend this a bit. That's 1, 2, 3, 4, 5, 6. Okay. So 2 hexyne will just be 1, 2. Are you getting it? You just put your double triple bond here. So that's that. So that's the chemical structure of it. Are you getting what I'm saying? Now, if you now want to draw the, let's say we want to draw the bond on end. Okay. Okay, let me leave it to us. Let's draw the structure of 2 pentyne. Oh yeah, I will come and check. So, sorry, let's draw the structure, the condensed form. Yes, condensed form of 2 pentyne. Yes, when you are talking of condensed form, you are talking of, you are having like CH2, CH3. Are you getting it? And the likes. So let's, I'll come and check right now. Let's draw the condensed structure of 2 pentyne. Alright, so don't forget that, as I established earlier, what you need to consider is the general formula, that's CnH2n minus 2. And when you're talking of CnH2n minus 2, pentyne here means that's C5H2n minus, that's 2 times 5 minus 2. That's C5H8. And that is telling you that you cannot have more than 8 hydrogen attached. Are you getting it? So now when you now apply the principle that carbon must be bonded to just 4 different atoms, I expect everybody to get this. So when you apply that principle, you will know that where to put your hydrogen. Okay, this one doesn't need hydrogen again, this one needs hydrogen again. But yeah, now please do that. If you have been following what you have been doing since morning, I'm sure you'll be able to get this. Alright. Some people have gotten it already, but look up. Please look up for those that are still confused on it. Now this is the hydrogen scope. We all know that but not have more than 8 hydrogens, Abby. So from that, you should know that okay, this we have 1 hydrogen, H, then H. Okay, then this one can have hydrogen and hydrogen here. This one cannot have anyone, Abby. This one cannot have anyone too. Then this one can have another 3, H and H. Okay, so if you now want to write it in condensed form, so just CH3, CH2, then C, then triple bond, then C again, then CH. Now we see that. As simple as that. So just apply it on. So that's how we'll do on that exercise. Apply it on the rest. So that's it. Follow the same principle. Just try. So don't forget. The more you make sure you try all those, do all those exercises. I've given you the principle to follow already. Yes. So once you are able to, so the more you are practicing them, the more you get familiar with them, and when you see them, you'll be able to recognize them easily. So if somebody is learning something. All right. So let's go. So now we move to exercise 2. Exercise 2. Now look at exercise 2. Okay. So that's where this is where we will apply what I call when you are talking of the longest chain. So when you see structure like that, that's where you can apply the longest chain or no longest chain. All right. Please come ahead. Okay. So I will name only one structure. Which one should I? Is it A or B I should name? Okay. All right. Let me start with A. Okay. Okay. Alright, let's look up. So in your skeletal structure, whenever you have a single stroke, that's methyl. When you have a double stroke, ethyl. We have triple propene. Okay, first let me count my longest chain. 1, 2. This my long. Let's say 1, 2, 3, 4, 5, 6, 7, 8. Can you see? Now let's count. Let me count first. Now let's count straight. 1, 2, 3, 4, 5, 6, 7. So if we name like this, we are wrong. Are you getting what I'm saying? So this is where the principle of longest chain that you have to count it. So when you are saying that it's coming, make sure that you do not just count straight. Now I was telling you that there are some that you cannot just count straight and name them like that. Alright, so let's count 1, 2, 3, 4, 5, 6, 7, 8. What if we are counting from here? 1, 2, 3, 4, 5, 6, 7. Or we count from here? 1, 2. So now let's see. 1, 2. So we have on the second carbon we have another substitute. of that are attached. So here to 1, 2. You can see that this one, there's nothing attached at the second carbon. So that means we are starting from this side. Is anybody confused?
Yes.
You are confused?
Yes.
Okay. Now let me explain. Before doing anything at all, the first thing you have to do is to establish which one is your longest chain. I get what I'm saying? That's what we should have done first. I hope you are getting it. So now, when we counted now, we are able to know that our longest chain is 8 carbons. Abi? From here now, look at the 1, 2, 3, 4, 5, 6, 7, 8. Look at it. So, but this is a branch chain now. 8 carbons. Now, if you want to count straight, you know we have been counting straight since morning, Abi? We have been counting straight since morning, Abi? If you want to count straight now, 1, 2, 3, 4, 5, 6, 7. So this is a straight chain, but it's not our longest chain. Are you get what I'm saying? So we can, if we name based on this chain, this straight chain, we will be wrong. How do you get what I'm saying? We will be wrong. If we name based on this straight chain, we will be very wrong. So as a result of that, we are going to use to name based on this longest chain. The longest we have is 8. Are you getting? No, let me show you other chains so that you understand what I'm saying better. Now look at it. 1, 2, 3. This is another chain now. Abi? But it's still shorter than this. Look at another chain. 1, 2, 3, 4. This is another chain. Do you agree with me? That's another chain. So now, when we decide to go straight, okay, let's say we want to name up to this level now. When we want to count up 1, 2, 3, 4, 5. That's another chain. But is there anyone that is up to 8? Apart from this one, No. So that's why we have to name based on the longest chain. Put that one on your mind first. Then secondly, we have to, just as we have been doing, the carbon, we have to start from counting from the carbon close to the functional group or substituent present. Okay, now let's take from this side. 1, 2. You can see that for the second carbon, there's a methyl there. Abi? Okay. Now let's start from this side. 1, 2, 3. You can see that before we go to where there's a methyl, another thing is substituent. You can see that we go to the third carbon. Are you getting it? So because after counting 1, 2, we were able to see a substituent. That means we start from that side. I get what I'm saying? Okay. So if we have to name that, we now say 1, 2. This methyl, Abi?
Yes.
Okay. 3, 4. Another methyl up here. Another methyl down. 5, 6. So this one now. So 5, 6. So at the 6th one, we have another methyl.
Yes.
I hope you are following me.
Yes.
Then 3, 6, Abi? 7, 8. So that's complete. So what we have methyl, that's 1, 2, that's 2, 4, 4, 2, 4, 4, 2, 4, 4, 6, that's 2, 4, 4, 6, tetra, methyl, which it is telling that we have 4 methyls there altogether. Are you getting what I'm saying? So 2, 4, 4, 6, we are stating the position. Tetra, methyl, then what's the parent name? Octane. So 2, 4, 4, 6 tetramethyl octane. So that's it. 2, 4, 4, 6 tetramethyl octane. So now look again. Let's name another structure. So you can see all of them. It's actually very simple. It's just looking as if it's hard. Now look. Look at here now. Chlorine. Okay, this one has double bond. Okay. 1, 2. Okay. Please let's listen. Now look at this now. When you are naming this 1, 2, 3. Now look at the first one we named. That first one does not really have any functional group. It just has substituents. Abi, it just has substituent like it has methyl. Am I right? Yeah. So, but this one has a point. So, what was it? What was it? It's an alkene. Abi. So, here now when you are naming, you have to name based on the fact that okay, let's count our longest chain. 1, 2, 3, 4, 5, 6. This is our longest chain. Okay, let's say 1, 2, 3, 4, 5. This chain is 5, Abi. It's not up to 6. Abi. 1, 2, 3, 4, 5, 6, yes, So which means that if we name like this 1, 2, 3, 4, 5, 6, or we name like this 1, 2, 3, 4, 5, 6. Anyone you name is still correct. How you are getting? Because it's still 6, you still get the same thing, still correct. Because 6 is the longest. Hope you are with me. 6 is the longest. So you still get it whether you name like this. You can go and try it when you get. So we just name on one stage. Okay, alright. So now let's go. Now when you have functional group like maybe alkene or alkyne, so you have to do your counting based on the carbon that is very close to the functional group present, to the whether double or triple bond. Are you getting it? So let's say we come from here now. 1, 2, 3. 1, 2, 3. Abi? Okay. Here too. 1, 2, 3. Anyone you do, whether from here or this here, is correct. Are you getting what I'm saying? The reason why it's correct is that since when you come from here, your double bond is at the third carbon. It's actually correct. And when you come from this side, 1, 2, 3, your double bond is also at the third carbon. That means it's, anyhow you do it is correct. And it may okay, let's say you come from here, your double bond is on the third carbon. And you come from here, 1, 2, it's on the fourth one. Or it's on the second, it would have been wrong. So you would have had to go for the lesser one. So does anyone understand what I just said now? Yes. So that's it. So when we are naming, we can actually name from any side here now, based on what we have counted. I get what I'm saying. Okay, let's say something. Okay, let's say, I want to quickly make an assumption. Please, look at it carefully. So let's assume our double bond is here. Let's assume, so that some people might not really get what I'm saying. When you count 1, 2. Now let's count from here. 1, 2, go to where I'm going. 1, 2, 3, 4. Now, which side are we going to count from? From the right side. The reason why I count from the right is that this one is very closer to the functional group present. I get what I'm saying? Very close to the double bond. So that's it. So anyhow you do it. So now let me return the double to where it is. Okay. So we can now choose any side we like. Let's assume we want to choose this side. That will be 1, 2. Okay, now, forget about the fact that there's something attached. Just look at this structure as if it is only double bond that is there. What's it? What's this? What's the name? What's it? What's the name of this alkene? Benzene. I'm hearing benzene. Hexene. I cannot call it hexene. Then what do you call it? X what? X3. The reason why it's 3 is because your double bond is at the third carbon. 1, 2, 3. So it will be X3E. I get what I'm saying. It will be X3E. If you count from here to 1, 2, 3, it will be X3E. So just start from the parents. Just if you start from identifying the parent compound, then it's very easy. Okay, now we already know that this one is X3 in Abi. And now we'll take note of the substituents. Now, let's go. So don't forget that we can count from actually any side we like. So let me count from here. I can start to count from here. 1, 2. So when I count 1, 2, this one that is lying somewhere is a substituent. Abi. So it makes it methyl. So when you are counting on your chain, on your longest chain, anything that you meet that is attached is a substituent. You name it as a substituent. Are you getting what I'm saying? So we have methyl here. Take note. Methyl here. Then 3, 4. Then we have chlorine here. Abi? We have chlorine. Then 5. Then we have methyl again. Abi? Then 6. Finally. So when you are now naming, now based on the alphabetical order we talk about, C comes before M. Abi? So it will now be, so now look at it. 1, 2, 3, 4, 5, 6. So it becomes easier that way. So now when we are naming, so we have 2 methyl, Abi, am I correct? So since C comes before M, so it will now be 4 chloro 2, 5 dimethyl X3E. let me write it. 4-chloro, 2,5-dimethyl X 3-ene. Have we written this? Yes. Okay, let's go. So when you are talking of isomers, please let's listen carefully. Let's listen carefully. You are talking of two compounds that are very similar. I get what I'm saying. So when we are talking of similar, that means they have the same functional group present. I get what I'm saying. They have the same atomic number. They have the same formula. I get what I'm saying. But the only difference between them is only in the way the functional groups are arranged, in the way they are attached to them.